So today I'm going to do arc length, tomorrow surface area. One is single units, the other one square units. This involves no axis of revolution. This one does involve an axis of revolution. So just a little FYI, your distance formula is good between 2 points. However, when you're calculating the speed of something, the shortest distance isn't always the fastest way to get there. Imagine if the ball is rolling down the incline from right to left. It goes some pace. However, if you shoot it down and up, it'll get there faster. So, not always is the shortest distance the fastest way between 2 points. Calculus can actually calculate the distances that might give you the fastest way to get there. And that's what people want. They want speed. They want to have you something quick. So after that, you'll be able to calculate that distance. Right now, you really can't. We're going to use a bunch of intervals, a bunch of tangent lines, and an offset distance formula to come up with that. Okay? Just as a quick review, 6-1 is the area between 2 graphs, I believe. 6-2 is the perpendicular rotation of that around an axis. So I was in pi r squared dx. 6-3 was the parallel rotation of that around an axis. And finally 6-4 was volume by cross section. Okay? A lot of stuff going on. Didn't seem like we could do this that long, but time's almost here. Yes?
So 6-5
Yes. You notice your practice test I put online is very original. It's got about 2 or 3 questions from each for a total of 15 questions. Pretty much, there's nothing hidden, it's pretty much straight up, you really not. So there you go. Last one today, the other one tomorrow. I'll review on Wednesday and Thursday. Okay? Thursday I might go through and do some more practice questions. I don't know. Maybe Wednesday I'll go through and do some more practice questions. Who knows? Okay? Anyway, that's the plan. Who? Oh, I will be. Oh no, there's going to be speaker here. And my staff class is going to be here. Me? I just told you. I might record a video or something. Alright, here we go. Notice one thing. You see this dx? What do you think these values are right here? X values. So we're going to give it a point. See the point? From A to B. Those are X values that we're going to use. You're going to find the bounds of integration for area. You're going to find the bounds of integration for length along a graph. So, not too difficult except typing it in. Here's one warning. A lot of people type it in as function integrate, and they put this in y1 because the variable is squaring it. Okay? So it says 1 plus the derivative squared is square root of that. Okay? I'm not going to do the proof of it. I'm sure you the application of it. You might get a professional that wants to prove it all. How do you know the difference is in terms of x versus in terms of y? This has a dy, correct? So notice how they wrote the definition. C and D, then G of D and G of C. Those are just the x values you can calculate. So, that's arc length. Not too difficult, I don't think. That might be in both today, depends on how it works. Ready? That way, we'll do this next day review for tomorrow and Thursday. Yeah. How do I do that? One's y and one's x. Okay? So, first thing you should do is do your test. There's not put your name on it. But whatever equations you want. If you open down y minus y, top minus bottom. Perpendicular is pi r squared d whatever. Parallel 2 pi r h d whatever. And arc length, cross section. And x dx. And then arc length. Square root of 1 plus f pi to x squared dx. That took how long? 46 seconds. Fine. Let me check this. Name last. People do this a lot at college. They practice what they're going to write for the first minute, 2 minutes of the test. It's a proven strategy that works. Okay? So, how are you supposed to remember all that? Easy. You practice. So, here we go. Is this one going to be a dx or dy integral? Probably dx, I would assume. Bounds? Well, because it says y equals. The bounds in this case? 27. Square root. 1 plus. F of x equals 2/3 x. What's the derivative? 2/3 x to the negative 1/3. Now down here, I just square the derivative. That gives an arc length. Okay? That one would, if I did it to include, be short something. What's it short? You have a graph, you have an angle, yes, you need the answer. You're correct. The L. 27. So, let's find the L. So, I'll put my derivative here. A safe place. It is. However, if I come across another one of these, I just have to change my equation, and I have to change my bound with it. So, math, observance, R's, y-R's, function y1 squared, comma, x, comma, $19.65. Yes.
I'm not sure that was being found on the graph.
It's not arc length, it's just the length from here to here along the graph. There's only good for straight lines. You have to use the right triangle. Right. Cubic function, sine, cosine curves? Yes. Sure? Muhammad. On my watch. Ready? Ready? Alright. We are going to find the length from here to here along this path. So, we can do y equals, we can do x equals, makes sense to me. Okay? So the x to the negative 2, y prime equals negative 2x negative 3. Can you punch it out? Nice. We take the video, need to subtract. Okay? That was the fact that I'm taking David's manual for about a month and a half. So, I'm going to go from negative 4 to negative 1. And Jake said it's L equals square root 1 plus y prime squared. Yes, dx. Okay. And just for sake of clarity, so I don't get actually right over here. Bracket negative 2 x negative 3 squared. Y equals 4. Now there's a recall, second recall, and change my bounds. Negative 4, comma, negative 1. I'm good to go, just in case. 3.038. That's how far it is if you took off and measured it. 3.308. There we go. Because we made that mistake, or you tell what I did to 3 points, I'd say, okay, let's hide. No. Just shoot you that. Okay. Okay, Jake. There's number 1. It's that game. Alright. I want to do this one. Find the arc length. The graph going to be. The numbers might guide your choice on this one. You want to do x's or y's for bounds. Then your equation will be of the form y equals. Well, the easy question of factors into our decision. The Spartans, no retreat, no surrender. Never back down. Real life, based on truth. The movie was negative. Here's slider, here's some jacket items. Negative x carrot 3 minus 1 divided by 4x. Okay. And the second one? The x is in the denominator, isn't it? Oh, I need to divide by 3. In the first one. Second, insert, divided by 3. There we go. Window. I think I'll go from 2 to 3 there, I think. Else I did right? No, yeah, I did. Well, it's better than 2 to 3, they're really wide bounds. So I'll go from 0 to 109 twelfths. Actually, 110 twelfths. That's not a minus and pressure you'll see, right? I thought I had a 0. Oh, 10? I think I'll add. Yeah, they give these values of 2 and 3 and they're both positive. Y equals negative x cubed divided by 3. It says cubed, doesn't it? I didn't find a picture of the distance of. y equals negative 1x cubed divided by 3 minus 1 over 4x. Right?
That's the one that, gotcha.
Second, calculate value. Next to 2. That's a negative number. Second, calculate value. That's 3. That's a negative number. Where's negative 9 divided by 12? That's right. So this has to be negative. That has to be negative. Yeah, I can't put in 2 positive numbers for x and y. I'm up to get 0. Something has to be negative. Absolutely, I tripped the book. That's negative. No, we're going with it right here. Alright. Never good. Just back off for a while and see what happens. So smart. Alright, so here's my points. 3 and negative 109 twelfths. And 2 and negative 67 24ths. Doesn't matter. We're going to factor in my calculation anyway. So, the derivative equals 3x squared over 3. Again, you drop it down, multiply, subtract. Think of this as negative 1/4 x to negative 1. So we plus 1/4 x to negative 2. So my derivative is going to be negative x squared plus 1 divided by 4x squared. Can we do that? So my integral will be from 2 to 3 square root 1 plus f pound of x I thought it was huge. Functional rates. I'm not storing y1, so I'm going to type that. 1 plus negative x squared plus 1 divided by 4x squared comma x comma 2 comma 3. Negative x squared plus 1 for x squared. All the other places for square root. Nice. 58. And I'll check student solutions after you after I'm done. Zachary. Alright, so here's our quiz. You're not? You keep saying that, but we don't believe you. Awesome. Alright. Now. Here we go. So, how do you find the surface area of a cone? I bet it's in your textbooks. Here's the axis of rotation. Yes.
Quantity to r squared.
Pi r times square root of what?
R squared.
The square root of that. I believe if this is r squared and this is h squared, that gives you, I believe it uses the letter L for slant height. I think so. Does that make sense? So, it is stands to reason that the radius, I put this on its side around the x-axis, rotate around the x-axis, it stands to reason if I have this line, and I use this as L, and rotate it around the x-axis, I can multiply that length, which is the slant height, which is the equivalent of r squared plus h squared, and I can multiply that by pi r, and find the surface area of that cone. So without looking, now we're looking a bit, pi times r L, in this case would be dx, because the radius is from the distance out, which would be the function value. So you have pi, r would be f of x, L would be the square root of 1 plus f prime of x squared dx. I have no idea if that's right, but I'm going to go looking for that. Sounds pretty solid to me. Why do you keep looking like you shit like that? What's your look at the book, see what I'm right? You say you're instructed. Yes. Yeah, I think I'm pretty good. It's pretty solid reasoning, don't you think? No, this is just a general thought. You have that every once in a while, correct? What's your watch? You have a cue what? Yeah, let's see. I'm curious, that'll be a lot. This one. I want to know, how do I find surface area?
Average radius becomes slant
2 pi
times average radius times slant height. That's surface area.
right. So what are you for integral? Oh, they're invoking an average for the dx. Gotcha. So that's the width.
So this one says f equals,
S, surface area.
yeah, it has the integral, and then it has 2 pi f of x, and then the square root of 1 plus f prime of x squared here. Aha!
So I was off by 2 because I failed to take into account the dx is part of the radius. The 1/2 comes out to the 2. So, pretty close. It wasn't slant height though, so that's good. So this is slant height. This is the radius. This account radius and the dx are also the radius. Here's if you scale a little bit, there's your second radius, you're going to be added to the 2. Okay? Ready to move on? So, we'll do 29, so Zach can check it to make sure it's right. You will do this in terms of y squared or y equals or x equals. Sure, let's go x equals. So x equals y squared over 4. So there's that. Oh, wait a minute. We're rotating around. We're on the x-axis, so we are required to go dx. Kind of cross sections. Shoot, that would have been fun too. So y equals plus or minus root 4x. Which means y equals plus or minus 2x. Now, Seth knows if I drop this out, yes. It's asking for the area resulting surface from A, which is 0, 0, to to B, which is 1, 2. The question is this y equals 2 squared root of x, or is it y equals negative 2 squared root of x? Which one's negative? The top or the bottom? Bottom. So I'm going to be using this equation. Because that's the piece or the branch I'm going to use to revolve it around. Knowing that this is L means that is the square root of 1 plus the derivative of x squared. Because now that piece is going to go around this axis, make your cone, and try to find the surface area. The radius is going to equal what? That's how far it is from here to here, or from here to here. 2x. Well, because that's the function value from the x-axis up to the curve is the function value. Right, or 2x minus 0. And that puts it as not moving. Oh, did you calculate it? Calculate. So, there's my picture. Here comes my integral. 2 pi, 2x, square root, 1 plus, or the derivative. That'd be a half times 2, wouldn't it? 2 times a half, x negative half, or 1 over the square root of x. Nice. Look at it, wait for that integral. I'm going from 0 to 1. You guys, they had to use dx for the other radius. Because when you have the radius, when you have dx, that value will be another radius. So it's only added to the radiuses. Take the average, you add, subtract, multiply, and divide by 2, you're going to be 2 out there. Kind of like the parallel rotation, the 2 pi and that, because dx is the average radius. Or, I'm sorry, the function value, f of x, is the average radius used. And these are the ones that people fell apart on when they try to tackle the other test. Clear. 2 second square root of x. This one, second square root 1 plus 1 divided by second square root of x. Close it off. So this is y1 and this is y2 in my work. Math 9 2 times I got y1 times I have to square this. I'm squaring this part. Second insert square. There we go. 1 plus, that's y1 squared. So derivative, okay. So I have plus, or times y2, right? Bars. You should know where I'll put it. At least that's the plan. If I'm off, I'm sure I know one person will let me know. Nice. I'll send this one out. I'll live on the edge. You gotta be kidding me. We rumbled and bumbled and stumbled our way through that answer. Well, we're just going to pile out here. That's we could. Nice job. I say we do one more, we're good. We do one with Zach and check. We do 33. Oh, P.S. There's always somebody misses the bus. They'll absolutely won't show up. Yeah, we've all run the y-axis. Y equals 2 subjects, math, math 4, that works. Clear. What's in room 6? So I'm not obviously going to use the whole graph, just apart from A to B. However, I'm going on the y-axis. So choose my integral, I have a definite dy flow to it. Okay. So the y-bound is like difficult. Nope. We have to go around the y-axis. So to calculate my radius, we have to find this value. So we're going to take y divided by 2 equals the cube root of x cubics. That means x equals y cubed over 8. Which means x prime equals 3y squared over 8. Yep.
So if it's longer on the x-axis and the y-axis, longer on the x-axis and the y-axis.
Right. How do you square that? That's pretty easy to square. How do you square that? 9y to the 4th over 64. You okay with that? I'm trying to bypass all this. So it 2 x caret 3 divided by 8. That's all? Then we have x of 2. So that's 69.95 pi. Great. So tomorrow I can review. Next day review. Test. Starts on Friday. I don't know what that's in 22 days. I don't know. I remember. Wait.
I have a question.